Hi, I'm Rodney, and I want to introduce you to a new tool I've developed, a desktop application for practicing FMC. I was inspired by the recent FMC Live event, in which the commentators had access to NISI for analyzing the scramble, and there was, again, smart cubes for visualizing things on the screen, but it gave me a vision for a tool that integrated all these aspects, and importantly, also included the super important aspect of competing in FMC, which is writing down solutions to many different EOs, solutions to many different ERs that you might find, going back to them, trying them on this, marking them as complete, and building out the whole solution from a bunch of possibilities. So I've finished V1. I'm releasing it. It's available for download. The link is in the description, and I'm going to show you how it works.
So this is what VFMC looks like. You've got your cube, of course, that you can drag around and orient. You've got your working solution space. So these are the moves that are showing in the cube right now. And then you've got a scratch space where you're writing down possibilities for all the different steps. I'm going to be using these GUI controls, but you actually have commands that you can type that are equivalent to any of these. So I can type help. It's the same help as I get from this drop-down menu. If I select EOFB, then I'm going to start working on edge orientation on the FB axis. Notice how, of course, I'm showing only the bad pieces. So this is kind of the key advantage of being able to do it on the computer instead of a physical screen, is it can highlight these for you. So you can practice your recognition. If I change to the axis, it brings that axis to the front. If you don't like that, you can change the orientation with these X, Y, Z buttons. I can also type EOFB, EORL here. Now, once I have selected an axis, I can double click here to start typing. So I can do LURF. And now, as soon as I get to 0 bad pieces, I can tell that I've solved it. If I tab out, it reformats it, and I can save, and it appears down here. So let me just find one on another axis. So here's one where L prime, say B prime, F2, U prime, R. So that's the 5 mover saved there, etc. I can NIS to see what it looks like on the inverse. Solve that, L prime. So yeah, see that's not a good continuation, but maybe I want to do L prime and then NIS and see if I can finish it on the front, etc. So I can build up these mixed solutions like that. I'm gonna now demonstrate how you can use the solver to kind of, if you want to shortcut this, you're not, you want to focus on a later step, or you just want to see if we missed anything, you can hit this solve button, and here I can see that it found a four mover. So if I hit solve again, it'll solve the next step. If I go back to EORL, I can also select the number to solve. Let's say I just want to solve look at a bunch of EOs without finding them myself. I can just get 10 solutions to EOs on that axis. So I'm just gonna populate a few different EOs just to demonstrate how you go from the next step. So when I double click on one of these EOs, now I've loaded this EO and I've gone to the next step, which is DR. DR, I have the choice of axis, of course, so I can look at the RL axis or the UD axis after an FB EO and start solving here. So notice on the RL, I'm at 4C4E, so I might want to make a note of that. So I can do that by going back to this EO and making a comment. So this is already an RZP. So I can make that comment here. So I know that maybe I want to prioritize that one. If I'm looking at the RUD, this one's not an RZP. I might want to start finding it. I can just start typing here. So R, I can type, looks what is UR, U2R, U prime R, right? DR, D2R, D prime R, L. So here's another RZP. I'm going to tab out here and save that. If I don't make a comment, it's going to, myself, in this case, it's going to add a comment of its own. So, they're automatically generated comments. These were just called EO, but here, since I'm partway, I hit RZP on DRUD, and so it gave me that comment. The other thing you can do, if you're finished checking something, say you can mark it done, and that gives it a strike through. So you can go through all these EOs, you can find your DRs, and build up a bunch of DRs. So I'm just going to do that by with the solve button. I'm just going to go to solve 1. So here's a solution. Here's a solution to that EO. Here's a solution to this EO. Here's a DR from this EO, right? So these are ones that I would find manually, but I'm just going to use the solver here to demonstrate. So now let's see, I've got a bunch of DRs. I can double click on them, and now I'm going to go to HDR. But let me first talk about the display. So if I double click this EO and I'm working on DR, what is being shown here? Now what's being shown here are the bad faces. So the bad faces, if I'm, let me go to a case with DRUD just to make it a little more familiar. So here I am, I'm working on DR on the UD axis. So there's 4 bad corners and 6 bad edges. To visualize that, all I really need are the bad faces, meaning the UD faces that are not on UD, the UD stickers that are not on the UD faces, and the non-UD stickers that are on the UD faces. So that's what's being shown here. That might not look so familiar to you, so you have some options here. You can decide under this DR recognition, you can control what's shown when you're at the DR step. So here by default, I'm showing the minimum, which is just the bad faces. But you can click here to show the bad pieces. So that's going to show the entire edge, both edges, both stickers of every bad edge. So here's a bad edge. It's only showing the bad face of the bad edge, but here if I click this, then I'll show the entire bad piece. Similarly here, this is a bad corner, but I'm only showing the bad face of the bad corner, but I can click here to show the entire bad piece if I want. Now, that of course starts to obscure things in the back and make it harder to see without dragging the cube. So if you don't want to drag the cube around, you have a couple options. You can use this transparency to make things visible. So I have it by default a little bit transparent. And the other thing you can do is hit the Option key here. This is just a shortcut. If you hit the Option key, it's going to hide the things that are in front. So that makes it easier to see what's on the bottom case. That these three are all bad, or maybe this one would be obscured, and so I can just see through that. So that's your option for visualizing. I still like the minimum, so I find that easiest. So well, whatever your visualization, you can load these EOs and find these DRs. And then if you load the DRs by double clicking on them, then you're working, of course, on HDR, in which you again have display preferences. The default display shows, for example, these some stickers on the UD face, because you need that for recognition too. So, but you should be able to solve and recognize the case just with the minimum amount. But whatever you're comfortable with, I can start typing in here to do and then that's going to be start solving HDR that way. I'm not going to bother doing that on hand. I have another video with a walkthrough, but I can just solve here. So let me just find the HDRs for the shortest HDR for each of these DRs. And now we can continue from these. So let me explain what's going on with this highlighting. So if I double click one of these solutions, now I've loaded this HTR, which into the display. So here's the full set of moves, this EO, this DR, this HDR. And the solutions that are being used are being shown in bold. So this HDR, bold, this DR is this one, this EO is this one, showing bold. If I click this one, then that came from this DR, which came from this EO. If I just single click, then I can actually see what the relationship is between these HDRs. So I can say, oh, what did this HDR came from? Oh, it came from this 5-move EO and this 13-move DR, and I can just kind of scan here to see like, oh, what have I checked? Because if I go through this EO, I can see, oh, I found a continuation from this EO, I found a continuation from this EO. So maybe those I would mark done, and this one I haven't found any continuation for, so maybe I want to load it and start working on it. Mark it done when I've finished. So let me continue on now from HDR. From HDR, the default step is to continue to floppy reduction, which you may or may not be familiar with, but if you are, then you'll know what this corner case notation is. Zero corners, zero corners, zero U2 turns is what that means, and there's 4 bad edges, so it's not quite in floppy reduction. But this one, if you're familiar, then you know how to solve that. Here's another. Right, so each of these are being shown with the case identification, and if you're familiar, you might know. Like, I think I know this one. This one is like a D2 R2, a D2, and that gets me to floppy reduction, so I can save that. After floppy, the next step is slice, so that would be in this case B2, F2. What is that? L2, F2, L2. Yeah. So there's my slice. And then finally there's finish, which you would normally do by insertions, which aren't handled by this tool right now. So usually I would stop here by slice. But if I'm finding manually, but the solver can actually do a finish. So if I load an HTR, I can actually go to finish. Now I'm just visualizing the whole cube, and the solver can find the finish from that HTR. One more thing to note is that you can load and save an entire session in VFMC and share it with other people. So if I just go here, I can load a session that I've looked at previously, and here's a run through that I did for the other video, and now you can see the whole thing. So here's the scramble. This is the solution I found, but you get, of course, all this extra information, not just the solution that I ended up finding, but how many EOs did I check? How many did I find? How many DRs did I look for continuation? Here you can see I found lots of continuations from this one DR. It was a 10 mover, so promising. I found one continuation from this DR that got me to reasonable floppy, but that was not too promising, and then I didn't bother with all the rest, and that's how I got to the solution. So after you're done, you can just save that, and that's just a text file you can email around. Once you just save it with a .vfmc extension, and if you do, then you can set up your computer so to open it with this when you double click on one of those files.
So that's the tool. I want to give a shout out to Jonas Balsfuland. You may be familiar with the Mallard online solver. The backend is what I'm using for the solver, the cube state tracking. It's got a great command line interface too. The result, I think, is pretty clearly the first computer aid that you can use to do an end-to-end full FMC attempt and get results comparable to what you would get on a physical attempt. And I just find it quite enjoyable to walk through, practice step solving, and also work on strategy, how to go deep versus broad, how to adjust the strategy if the scramble is particularly easy or particularly hard. And I hope you find it enjoyable and useful too. If you have feedback or suggestions, let me know.